Hi, my name is Lindsay Olteen, and this is my video homework 3. Starting off with problem 1, we are given 4 inverse equations of cosine and sine. So, starting off with cosine inverse of radical 3 over 2, this is equal to pi over 6, because cosine is equal to positive radical 3 over 2 at pi over 6. Cosine inverse of 0 is equal to pi over 2, and sine inverse of 1/2 is equal to pi over 6, and sine inverse of negative 1/2 is equal to negative pi over 6. So on the cosine inverse graph, you can see where I've plotted cosine inverse of 0 and cosine inverse of radical 3 over 2, which are both shown at pi over 2 and pi over 6. Now on the sine inverse graph, you can see where I've plotted negative 1/2 and positive 1/2, and they're at negative pi over 6 and pi over 6. Problem 2. Starting off with 2 sine 3x minus 1 is equal to 0. We move that 1 over, and so we get 2 sine 3x is equal to 1. Since sine 3x is equal to 1/2, a sine angle that's equal to 1/2 is equal to pi over 6, or 5 pi over 6. Then we can put 3x equal to pi over 6 plus 2 pi k. Once we have that, to find the value of x, we divide everything by 3, which gives us pi over 18 plus 2 pi k divided by 3. And also, x is equal to 5 pi over 18 plus 2 pi k divided by 3. So to find the values in a comma separated list, what you're going to want to do is plug in an integer for k. So in this case, we plug in 1 and 2 for both equations, pi over 18 plus 2 pi, and 5 pi over 18 plus 2 pi over 3. And we get pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. Now for the second problem, tan squared x minus tan x minus 2 is equal to 0. So the first thing that we can do is we can shorten this down and factor it, so we can make that whole equation t squared minus t minus 2. So we can just factor that normally, and we can get t plus 1, t minus 2, making tan x equal to negative 1, and tan x equal to and tan x equal to 2. So when tangent is at negative 1, the angle is negative pi over 4 and 3 pi over 4. And tan x is equal to 2 doesn't have an exact angle. So using negative pi over 4 and 3 pi over 4, we can create the equation x is equal to negative pi over 4 plus pi k, and x is equal to 3 pi over 4 plus pi k. Now doing the same thing as part A, we can plug in an integer for k in both equations. And so we will get the comma separated list as negative pi over 4, 3 pi over 4, 7 pi over 4, and 11 pi over 4. Now to problem 3. Part A is 2 cosine squared x minus 7 cosine x plus 3 is equal to 0. So just like the last problem, we're just going to make this easier to factor. So we can change that whole equation into 2x squared minus 7x plus 3 is equal to 0. To make it even more simpler to factor, what we're going to do is we're going to separate negative 7x into negative 6x minus x. And then take out 2x and negative 1, so we get 2x times x minus 3 minus 1 times x minus 3 is equal to 0. And since there's two x minus 3's, we can just take out one of them, and so it'll be a 2x minus 1, x minus 3. So our x values will be 1/2 and 3, but cosine is not possible at x is equal to 3. So we're going to work with x is equal to 1/2. Cosine x is equal to 1/2 at pi over 3 and 5 pi over 3. So our equations are going to be x is equal to pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. Plugging in integers, we'll get pi over 3, 5 pi over 3, 7 pi over 3, 11 pi over 3, 13 pi over 3, and 17 pi over 3. Okay, so part B, we are given 1 plus sine x is equal to 2 cosine squared x, and we can solve this using the formula sine squared x plus cosine squared x is equal to 1. So since cosine squared x is found in the original problem and it's found in the formula, we can just subtract sine squared x from 1, and then we're given what cosine squared x is equal to. So we can change that into 1 plus sine x is equal to 2 times 1 minus sine squared x. Now we're just going to multiply out that 2, so we can get 1 plus sine x is equal to 2 minus 2 sine squared x. Move everything from the left side to the right side, set it equal to 0, and further simplify, and now we can factor. So we can turn that sine x into just x, so we get 2x squared minus x plus 1 is equal to 0. Factor it out just like we did the last problem, separating negative x into negative 2x plus x. And so we can get negative 2x times x plus 1 times x plus 1 is equal to 0. Because we have two x plus 1s, we could just mark that down to 1. So we get negative 2x plus 1 times x plus 1 is equal to 0. Set both of those equal to 0, and we get sine x is equal to 1/2, and sine x is equal to 1. Sine x is equal to 1/2 at pi over 6 and 5 pi over 6, and sine x is equal to negative 1 at only 3 pi over 2. Set those into our equations. X is equal to pi over 6 plus 2 pi k. X is equal to 5 pi over 6 plus 2 pi k. And x is equal to 3 pi over 2 plus 2 pi k. Add it or multiply in integers, and we get pi over 6, 5 pi over 6, 3 pi over 2, 13 pi over 6, 17 pi over 6, and 7 pi over 2. Now to problem 4. So we're given 3 problems to graph, and we can graph these by looking at the original graphs of y is equal to them. So for y is equal to 2 plus 2 cosine x, we're trying to find r is equal to 2 plus 2 cosine theta. Um, so when we look at the graph, we can see where it starts at 4 and then moves all the way to 2, and then it has an x value of 0. And so it comes back out and circles back around to 4. With the second one,